Hi students, this part of your mole concept we are going to look at empirical formula, molecular formula and structural formula. Okay, so for example, water, we have the molecular formula H2O. The empirical formula is also H2O, and empirical really just means the simplest formula. Okay, molecular formula means how does the molecule look like. Okay, so butane has this molecule C4H10. There are 4 carbon atoms and 10 hydrogen atoms. The structural formula, so this structural formula essentially draws out all your bonding. So each line represents a covalent bond. Remember, carbon got 4 valence electron, it can form 4 bonds with 4 lines coming out from carbon. Hydrogen got 1 valence electron, it can form 1 bond. So each hydrogen you see 1 line coming out. Okay, so C4H10 is the molecular formula. The empirical formula is C2H5. C2H5 is the simplest formula. So in other words, right, we can also represent it as N times, right? So N will be equals to 2. If N is equals to 2, then you will have C4H10. Okay, hydrogen peroxide, H2O2. The formula, the structural formula looks like this, and then the simplest formula is HO. Okay, so using this idea, we have this formula over here. The molecular formula equals to N, empirical formula, where N is the ratio. So if I use this example of C4H10, okay, equals to N, empirical formula C2H5. So by right, if I count it, N will be equals to 2. So that is their ratio. Okay. So using this idea, we are able to count some of the questions to count your empirical formula as well as determine your molecular formula. Okay. Looking at this example, let's take a look. I have 0.48 grams of magnesium, and this one is burned in oxygen to give me 0.8 grams of magnesium oxide. So the question asks me to find the empirical formula. Okay, moving forward, empirical formulas and molecular formulas, you have to present it in this table. Okay, so the first presentation is 0.48. The first row is your mass. So 0.48 grams of magnesium, and then 0.32 grams of oxygen. How did I get 0.32 grams? Is using the information of 0.8 minus 0.48, 0.32, right? So this is the compound 0.8 magnesium oxide over here. Okay, 0.48 is magnesium, right? So this balance has to be oxygen. So your elements put on top, magnesium, oxygen, the mass. So once you have the mass, apply the formula mass over molar mass. Okay, let me write it down. Apply the formula mass over molar mass. Molar mass you get from your periodic table, and this one will equivalent to your mole. Okay, so same thing, 0.48 divided by 24. You get this amount, and 0.32 divided by 16. So 24 is the relative mass of magnesium, 16 is the relative mass of oxygen. So if you count it, you get 0.019, 0.02. So the next step that you do, right, is to divide by the smallest number. Okay, to find a ratio, you divide by the smallest number. So 0.0198 is smallest, so you divide it, you get 1. And 0.02, you divide it, you get 1. So the ratio is 1:1. Therefore, my formula have to be in a 1:1 ratio, MgO. Okay, another question over here. A gaseous nitrogen oxide contains 30.4% nitrogen and 69.6% oxygen by mass. Okay, so by mass means this one you have to assume 100 grams. Okay, if there's 100 grams of nitrogen oxide, right? 100 grams, 30.4% is nitrogen. So 30.4 grams is nitrogen, 69.6% is oxygen, 69.6 grams, because I assume 100 grams. Okay, so have the mass, then this one same thing, this is to the mole equals to mass over molar mass. So 30.4 divided by 14. 14 is the molecular mass of nitrogen. You get 12.7. And then 39.6 divided by 16. Again, 16 is your molecular mass of oxygen. You get 4.35. Okay, do the mole ratio. How do you do it? Divide by smallest. Okay, so divide by the smallest number. Let me count this out again. 30.4 divided by 14. This is 2.17. Okay, so 2.17 you should divide by the smallest number. You get 2.17 divided by 2.17. You have equals to 1. And then 4.35 you divide by 2.17. You get approximately 2. So the ratio is 1:2. So what does this mean? There's 1 nitrogen to 2 oxygen. So your formula is NO2, and this is the empirical formula. Okay, another part to this question is when they say that the molar mass. So the molar mass is 92. In other words, means if I add up all the mass of all the atoms that are there, it will add up to 92. So apply back this formula, MF equals to NEF, right? So MF is 92, okay? NEF, EF, what's your EF? 1 nitrogen, this is 14 plus 16 plus 16. Okay, and then you should get, this one you should get 46. Okay, so 92 equals to n times of 46. Yeah, 92 equals to n times of 46, and then n equals 92 divided by 46. So 2. So my ratio is a 2 ratio. So the whole thing, I should have a 2. So your molecular formula is N2O4 over here.